Alright, practice exam day 1, pages 1 through 3. I'm going to go through these problems, try and give you some helpful pointers, and make sure that you remember what you need to for this. For 1 through 3, you're just going to first of all simplify them. In the first one, we're going to distribute here, and I get 2x squared minus 6, 7x squared minus 5x, plus 5x, and then combine like terms. Negative 5x and 5x cancel. That will give me 9x squared minus 6. LC is for leading coefficient, which is the number in front when you write it in standard form. And standard form, remember, means from greatest to least. So in terms of exponents. So my leading coefficient here is 9 because it's the one in front. And this is a quadratic binomial. So we've got our terms here. 0 is constant, 1 is linear, 2 is quadratic, just did that one, 3 is cubic, 4 is quartic, and 5 is quintic. That's based on the degree. The number of terms, 1 is a monomial, 2 is a binomial, 3 is a trinomial, and anything 4 or more is a polynomial of 4 terms, or 5 terms, etc. That's the number of terms. And that's how we name them. So for the next one, I'm going to FOIL this out first. X squared plus 5 minus 3 is plus 2x minus 15. And then I'm going to just distribute that x squared. So I have x to the 4th plus 2x to the 3rd minus 15x squared. And here my leading coefficient is 1 when there's nothing there. Remember, that's a 1, not a 0, because that would make it go away. And this is a quartic trinomial. Last one, I'm going to rewrite this out. X minus 3, x minus 3, x plus 3. Now when I do it that way, I could FOIL this out, but this is a lot easier if I do this first. Because that's going to give me, well, I'm going to write it up here, x minus 3 times x squared. I've got a minus 3x and a plus 3x that are going to cancel each other out. Then minus 9. Then to get my standard form, I'm just going to FOIL it out. X cubed. I could do this one, but I want to keep it in standard form, so I'm going to do the x squared term next. Outside, negative 9x. And last gives me plus 27. Again, my leading coefficient is 1 when there's nothing there. This is a cubic polynomial of 4 terms. Okay? Going to tell you, the four terms below, you need to memorize that. Poly of 4 terms is probably going to show up on your exam. And then for the other ones, you just need to remember what's what. Constant, linear, quadratic, cubic, quartic, quintic. Those are things you need to memorize. Okay? For problems 4 through 9, it is just a matter of solving for x. In this problem, of course, we'd minus 5 first. And divide to get negative 6. Simple as that. You can plug it back in to check. Negative 4 times negative 6 is 24, plus 5 is 29. It works. I'm going to minus 5x on both sides here and add 13 at the same time. This way I see something canceling on each side, which has to happen. This is more algebra review. We did this the first couple weeks of school. X equals 4. 20 plus 7 is 27. 40 minus 13 is 27. It works. In this problem, if I minus 4x to both sides and add 6, these cancel, these cancel, these cancels. 11 equals 0, and that does not work. So that is no solution. Okay, on this, negative 2 minus 5x plus 10 equals 16 minus 13x. Combine my like terms here. I get negative 5x plus 8 equals 16 minus 13x. Bring some terms to the one side, so I'm going to bring the 13x over here, and I'm going to bring the 8 to the other side again, because those will cancel and those will cancel. and I get 8x equals 8, and divide to get x equals 1. Okay? Again, distribute, negative 5x minus 15, 2x minus 8 plus 7. Those I'm going to combine to get negative 1, so I can just kind of do my thing to both sides. 5x that I'm going to add, 1 that I'm going to add, and I get these to cancel, 7x. I get these to cancel, negative 14, and divide to get negative 2. Okay? Distribute this, 6x minus 2x minus 6, negative 10, distribute this, plus 8x minus 8. Again, these two are going to combine to give me negative 18, and I can do these two combine to give me 4x. Bring the 4x to both sides. Bring the 18 to both sides. These cancel, 12 equals 4x. Divide to get x equals 3. And again, I could keep plugging these in to double check myself, but I have done these before, so I know they're right. Okay. Down at the bottom, it's a linear programming problem. You are going to have one of these on the exam. So if you don't remember how to do this, you graph each one of these by setting the x equal to the number and the y equal to the number. So here I've got x equals 5 and y equals 5. That's easy. Go plot that. Y equals 5 there, x equals 5 there, and connect your dots, which I'm going to try and do freehand. And then shade it. And if you don't remember, we plug in the 0. 0 less than or equal to 5. It works, so I shade towards 0, 0. Okay. For the next one, I'm going to set 4x equal to 8 and y equal to 8. Well, that tells me that x equals 2 and y equals 8. So x equals 2 right here, y equals 8 right here. And again, I'm going to try and do this freehand here. And again, I plug in 0, 0. 0 is less than or equal to 8. It works. So that line gets shaded this way as well. I've got, now the reason that I need to use maybe a straight edge to do this is because my point of intersection is right there, right there, right there, and right there. That's what these are bounded by. Okay? So those are the vertices I come up with. 0, 0, 0, 5. This point is 1, 4. And this point is 2, 0. Now, if you don't know how to find that 0.14, if it's not visible because you tried to do it freehand like I did, well, then maybe you need to set these kind of x plus y equals 5, negative 4x minus y equals negative 8 by using elimination, which we're going to do on the next page anyway. These cancel, negative 3x equals negative 3, divide to get x equals 1, and plug that back in. If 1 is here, I bring to the other side, y is 4, there's my point. Now I plug them into the objective function. 0 plus 0 is 0. 0 plus 15 is 15. 1 plus 12 is 13. And 2 plus 0 is 2. Which one of them maximize it? Well, it's the maximum value. So 0, 5 is my maximum for P. Next page. Okay, for each one of these problems, what I'm going to want to do here is similar to what I was doing on the previous page in terms of finding the x and y intercept. So I'm going to set each term equal to that value. So 4x equals negative 8 and negative 2y equals negative 8. Divide to get x is negative 2 and y is 4. Plot those points. Y is 4 there, x is negative 2 there. Connect my dots. And that's it. That's all you got to do. Okay? Y is greater than 3. This is the y-axis, this is the x-axis. Y has to go through the y, and y is 3 right here. Now this is a less than sign, so I need to do this as an inequality, which is a dashed line. Difference between a dashed line and a solid line. Solid line, like this, is straight up less than or equal to. Okay? Now, when I talk about plugging in 0 to check, is that a true statement? Yes. So this gets shaded towards 0. If it is false, it would shade away from 0. And that was the case on the previous page, but both of them happened to work, so they both shaded towards 0. Same thing here. 3x equals 6. 2y equals 6. X is 2. Y is 3. Right there. Right there. Combine them. Solid line because it's greater than or equal to. Plug in 0, 0. Is 0 greater than 6? No. So I don't shade towards 0. I shade away from 0. Inequality should always have shading. That went y, so it went through the y. If this is through the x-axis, then this better be x. Okay? And in fact, it is x. Is it less than or greater than? Well, I know my number is -2 because it's going through -2. It's better have an equal sign to it because it's solid. If I plug in 0, what I need is for this to be a false statement. So -2 is not greater than, so I can go like that, and there's my answer right there. Okay? Solving the system by graphing, down at the bottom. I've got my first problem, start at 1, up 2 over 1, up 2 over 1. I can go the same direction the other way, and I'm going to, just so that when I draw freehand here, it's relatively accurate. I'm going to graph my other equation at 4, up 1 over 2, and I already see my point, but I'm just going to finish the rest, because the answer is the point of intersection. And the point of intersection, you can see from the graph, is 2, 5. That should work when I plug it back in. If I plug in 2 here, 4 plus 1 is 5, that works. Half of 2 is 1 plus 4 is 5, it works, and it should. Same thing on the next problem, positive 1. I've got to go up 1, left 2, because that's what that negative means. Up 1, left 2, or I can go down 1, right 2. I'm going to do that just so that I get this. Again, it's a solid because of the greater than or equal to sign. Now this is an inequality, so there's some shading involved, and it even tells you the answer is the double shaded region right here. 0 greater than or equal to 1, that's a 1 from there, because when I plug in 0 here it goes away. That is a false statement, so I don't shade towards 0, 0, I shade away from 0, 0. Next line is at -3, and it's up 1 over 1, up 1 over 1. So I'm going to do a dash line there, because it's not equal to, it's just strictly less than. Plug in 0, 0, is 0 less than -3? Nope. So again, I don't shade towards 0, 0, I shade away from 0, 0, which tells me that my double shaded region, which I'd like to make sure is a little darker so I don't have to guess, is right there. And that's it. That's the answer for that problem. Okay. Now that kind of concludes all the review type of problems, save for what's at the top of this page here. Okay. Now, what am I doing at the top here? Solving systems here. For this problem, I know what y equals, so I'm going to go ahead and plug it right there in for y. -4x plus 2 times -3x minus 1 equals 8. Do the math. Distribute it. -6x plus -2 equals 8. Combine my like terms. Bring the 2 to the other side. And I get x, of course I divide, x equals -1. But here's the thing, to solve a system, the solution is a point. Okay, and the point, well, x equals -1, what do I do to get the y then? Plug it back in. -3 times -1 is 3, minus 1 is 2. There's my answer. Could I plug it back in here? Sure. -4 times -1 is 4. Bring it to the other side to make that 4. Divided by 2 still gives me 2. It should work for both. In this problem, there's nothing I can just cancel or eliminate, so what a lot of times we've done is just multiply a line by something, which is what I'm going to do. Multiply that whole line by 2. Now, keep in mind what's happening here. These cancel because they're opposites. Those I add up. These do not cancel. They are not opposites. They are the same. Now I divide by 12 to get y equals -3. And I'm going to have to plug it into one of these two values. It doesn't matter which one. I'll just plug it into the second one. 2 times -3 equals -18. This is -6. Got to bring it to the other side by adding 6. And then divide. And I get x to be +2. On this problem, y equals y, so I can just set them equal to each other. Bring the x over to one side. Bring the 13 to the other side. Those cancel, those cancel. 5x equals 25, and divide to get x to be 5. Again, go back and plug that in to either one of them. 20 minus 13 is 7. -5 plus 12 is 7. They both work. There's my answer. Okay. Alright, let's get down to the graphing. Now, what you'll notice here is there's one that's in regular form, standard form, and there's one that's in vertex form. The one in standard form, what you need to remember is, first of all, the axis of symmetry is x equals the opposite of b over 2a. So, I've got x equals, the opposite of b is negative 8, 2 times negative 2 is negative 4, and I get 2 from that. That is always the same as this value, and that works in all of these, even down here. Now, when I do this, I got to plug 2 in. So plug in 2, or whatever that number is. I'll plug it in here. Negative 2 times 2 squared plus 8 times 2 minus 2. Negative 2 times 4 plus 16 minus 2. This is negative 8 plus 16 minus 2. 8 minus 2 is 6. So I get my vertex 2, 6, and I'm going to go plot that right away. I get 2, 6 right there. My y-intercept is always 0, comma, plug in 0. And when I plug in 0 here, I get 0 plus 0 minus 2, which is negative 2. Let's go plot that, and then reflect it over here. So that ends up at 4, negative 2 for my reflection. Okay. For point 3, plug 3 in, so I get negative 2 times 3 squared plus 8 times 3 minus 2. This is 9 times negative 2 is negative 18. This is 24. And 6 minus 2 is 4. Okay, so I've got 3, 4 right here. That reflects here because there's my axis of symmetry. Maybe I should draw that in there. You don't need to, but it helps. That reflects the 1, 4. There's my point. I'm going to connect my dots. So I got my parabola. Pardon for the crude drawing because I'm not an artist. And there's that. Now, for increasing and decreasing, what I've said before is if we draw a number line here and we figure out where it's increasing and where it's decreasing, it's increasing here because it's going up. It's decreasing here because it's going down. So increasing is going to get this arrow. Decreasing is going to get that arrow. So I've got x and x. Increasing gets this arrow. Decreasing gets that arrow. And the number is always whatever the axis of symmetry is. And now I'm done. Okay. Go on to the next problem here. This is really easy in terms of the vertex and the axis of symmetry because the vertex is given right to us. It's opposite same. So 3, negative 4. I'm going to go plot that. Oh, it's going down by 2s, keep in mind there. So that's why my point is there. Axis of symmetry is always the same as that, just like it was up above. My points, I'm going to have to plug 1 in. 3 times 1 minus 3 squared minus 4 is 3 times negative 2 squared, which is 4 minus 4, and 12 minus 4 gives me 8. So 1, 8 is right there. Where does it reflect to? Well, here's my line of symmetry, so I got to go 2 more away in that direction, and I get 5, 8 as my reflection point. For 4, I'm going to plug it in. This is 1. 1 squared is 1, times 3 is 3, minus 4 is negative 1. I know that's going to be there. 4, negative 1 is right there, kind of in the middle, right? Now, from there, I've got to reflect it over here to 2. So 2, negative 1 is my point there. Okay. And there's my reflection there. Done. Increasing, decreasing. Again, maybe I should draw this out first. It is decreasing this way. It is increasing that way. So decreasing gets that x. Increasing gets that arrow. And again, it's whatever your axis of symmetry is. In this case, 3. Okay. The very last problem on this page just asks if it opens up or down. It is always dependent on A. Depends on A. Up means positive, down is negative. This has a negative 3, so it's down. And again, the reason why is because A is negative, so it's down. If positive, it would be up. Okay? That's the first 3 pages. That's what you are to do for tomorrow. Please work through this. Make sure that you're kind of getting what's going on here and ask questions as you have them.